Okay, so welcome to all of you. So last time we have seen the forward difference. Okay, now we'll see backward differences. So here we will see the backward differences. So what we'll do for this one? So take a function y is equal to f of x as a single valued function and it is continued on the interval x0 xn. Divide this interval into n sub equal intervals. So that means what? So divide this interval into n equal sub intervals. So equal length. That means what? x0 plus h, x0 plus h, x0 plus twice h, and so on. Okay. So then the difference is f of x minus f of x minus h, f of x plus h minus f of x. Okay. Dot dot dot. The f of x plus nh minus f of x plus n minus 1h are called backward differences, and h is called interval differencing. The backward difference operator is denoted by this nabla, and it is defined as nabla f of x is this. Okay. So now this is the definition of the backward difference. For this one, for forward, we are applying this. This is what delta f of x plus h minus f of x. So here what we are doing, that we are doing f of x as it is here. Here f of x is what? Minus f of x here. What we are doing here? We are subtracting h from the x now in the second one. So minus f of x minus h. Okay. So that means what? Suppose if you want to find this nabla f of x plus h, what you have to write? The function as it is you have to write. Then minus subtract h, replace x by x minus h. So that means this is what? This will be the x. Okay. So if you want to find nabla f of, this is what? The first backward difference at f of x plus twice h. This is what then? F of x plus twice h will be as it is, minus replace x by x minus h. So x minus h, so this becomes x plus h now. This is f of x plus h, and so on. So in this way you can find the backward differences. Okay. E is called, this is what? Nabla square. E is called second backward difference operator. Second difference operator. Second backward difference operator, and is defined as square is nothing but what? This I we can write this is what? F of x. So how we can simplify this? Nabla f of x is what? F of x minus f of x minus h. Now again we have to apply this. So what I have to do? This function as it is now, f of x minus f of x minus h as it is, minus replace x by x minus h. So this is what then? F of x minus h minus f of x minus twice h. X minus h minus h. So we are replacing x by x minus h. X minus h minus h. So this will be x minus twice h. We simplify this. So what we get then? F of x minus 2 f of x minus h plus f of x minus twice h. Okay, this is nabla square f of x. Then this is what? Nabla cube is called third backward difference operator, and is defined as nabla cube f of x is same as nabla square f of x. So just we have calculated nabla square f of x, second backward difference. Okay, so we'll apply that one. So this is what? Nabla. So this is what? F of x minus 2 f of x minus h plus f of x minus twice h. Okay, so this is equal to, first this will be as it is. Okay, So f of x plus this this is as it is now. This is f of x minus 2 f of x minus h plus f of x minus twice h minus, you have to replace x by x minus h. So what we get then? F of x minus h minus 2 f of x minus twice h, then f of x minus 3h plus f of x minus 3h. Okay, and after simplification what we get? This is what f of x will be as it is, because it is a single term. So now this is minus 2 f of x minus h, and this is what? X minus h, minus minus, this is minus, so this minus 2 and this minus 1, so this is what? Minus 3 f of x minus h. Then this is what? Plus f of x minus twice h, that minus, so that will be okay. So it will be what then? Minus minus, how it is? Oh, okay, okay. So this minus 1 become plus now. So plus 2 times f of x minus twice h, and this is minus f of x minus 3h. Okay. Okay. So this is f of x minus twice h, and this is f of x minus twice h. Minus 1 become plus. This is plus 1. This is plus 2. So this becomes plus 3 now here. This is 3 now. 3. So this is what? F of x minus 3 f of x minus h plus 3 f of x minus twice h minus x minus 3h. Okay. So in this way you can find the backward differences, and this is the definition of the backward differences also we are applying here to find second difference, third difference, fourth difference, and so on. Now we'll see what we mean by shift operator. Shift operator. Shift operator. Okay. Shift operator is denoted by capital E, and it is defined as E of f of x is equal to f of x plus h. Okay, E square f of x is same as E f of x. So this is what? E of f of x plus h. So to operate the shift operator, what we have to do only? We have to replace x by x plus h. So it will be what then? F of x plus twice h. Okay. So therefore, e raised to n f of x is equal to f of x plus nh. Okay. So that means e raised to minus n, we can write this is f of x is equal to f of x minus nh. So e raised to half also you can write this is what? F of x is equal to f of x plus half h. Okay. So e raised to minus half f of x, this also we can write this is f of x minus h by 2, and so on. Okay. So we can write this. So now we'll see what relation among. So also we can write this is what? E of yx. E of yx is equal to y of x plus h, and E of yn is same as we can write this what? Y of n plus 1. E of y is equal to n plus 1. Okay, and e raised to r yn is equal to yn plus r. If it is in terms of x, so this is what? E raised to n yx is nothing but y of x plus nh now. In terms of x, you have to write x plus nh, but in terms of yn, you have to write just n plus r. Okay. So in this way you can operate E on yx or yn. Okay. Now we'll see the relation among So 1. 1. Second, we'll prove this. We'll prove this. Okay, so proof. Proof. Okay, so 1. Delta f of x is equal to f of x plus h minus f of x. We call this as 1. Okay, now e minus 1. E minus 1 f of x is equal to e f of x minus f of x minus f of x. So e f of x is nothing but f of x plus h minus f of x. We call this as 2. So from 1 and 2, delta f of x is equal to e minus 1 f of x. So therefore delta is equal to e minus 1, or delta is equivalent to e minus 1. Okay. So now the proof of it is what? Just we are applying the operator now. Definition of the operator here. Okay. Now second one. So e f of x. So this is what? F of x plus h only. We'll call this as 1. We'll call this as 1. Okay. So now 1 minus delta raised to minus 1. Okay. So okay, we'll do for this one. What happened here? So instead of this one, actually, so e is equal to 1 minus delta raised to minus 1 implies that e raised to minus 1 is equal to 1 minus delta. That will prove now. So e raised to minus 1 f of x is equal to f of x minus h. We call this as 1. We call this as 1. Okay. So now 1 minus nebula f of x. So this is f of x minus nebula f of x. So f of x minus nebula. Nebula means what this? This is f of x minus f of x minus h. This is the definition of the backward difference operator. Okay. Now your f of x get cancelled, and this is what? X minus h. We call this as 2. Okay. So therefore e raised to minus 1 f of x is equal to 1 minus nebula f of x. So therefore e is equal to 1 minus nebula, and this is same as e is equal to 1 minus nebula raised to minus 1. We will take the power minus 1 on both sides, because product of the minus 1 and minus 1 is 1 now here, and it will be the minus 1. Okay. So both are the equivalent. Okay. Now we will do the third one now. So this is what? Forward, backward. We will apply this on f of x. So this is nothing but a forward. We will apply this on backward f of x. So this is forward difference delta. We will apply the definition of the backward difference. This is what? F of x minus f of x minus h. Now we apply the forward difference operator. So forward difference operator is what? You have to write x and x plus h. So in the first bracket, x plus h minus f of x minus f of x. Replace x by x plus h, and then subtract this as it is now. So your this is what? F of x minus f of x minus h. So what is this? F of x plus h, f of x plus h. This is minus minus, so minus 2 f of x plus f of x minus h. Okay, so this is what forward into backward of f of x. I call this as 1. I will call this as 1. Now next one, minus nebula f of x. So this is what? This is f of x minus backward f of x. So we'll apply the definition now. So what is the definition? This is what? F of x plus h minus f of x minus. Now first backward difference operated on f of x is what? Your function as it is, minus f of x minus h. So this will be what then? F of x plus h minus 2 times f of x plus f of x minus h. We call this as 2 now. This is what? So if you want to do the number, then both LHS and RHS should be completed here. Okay. So from 1 and 2. So from 1 and 2. From 1 and 2. F of x is equal to f of x is equal to f of x. So therefore forward into backward is same as forward minus backward. Right? Forward into backward is same as forward minus backward. Okay. Now next, prove or disprove. Okay. Prove or disprove. 1. Oh, this is backward. I want to write here what? Forward into backward is same as backward into forward. Okay. Second, forward minus backward is same as backward minus forward. Prove or disprove means what? You have to check whether this is true or not. So this is exercise to you. So check this is what? This is hold or not. So operate this or just we have calculated this now. Just we have to calculate this now. First we have to operate a forward difference, then you have to operate backward. So then you have to check this difference. Okay, whether they are true or not. Whether true or if these two are equal, then these two will be equal. If these two are equal, then these two will be equal. Okay. So I think this is not true. So both are the not true. That means what? Forward into backward is not same as backward into forward. Because a minus b will not be same as b minus a. So this is not true actually. So question will be like this: what? Prove or disprove. That means check whether these are equal or not. So if they are not equal, just write this. If this is not equal, just write this one. If this is not equal, just write this one. Okay. So that you have to check. Prove or disprove means. Okay. I hope that you can do this one. You can do this one. You can check whether these two are equal or not. Okay. So that is the exercise to you. Now we see some examples on this forward difference, backward difference, and this. So evaluate del square x cube. Okay. Solution. Del square x cube is equal to del of del x cube. So this is what? Oh, this is forward. Okay. You have to take the care of this one, forward and backward. So what is that? X plus h cube minus x cube. Okay. Now operate this now. So this is what then? X plus twice h cube minus x plus h cube minus, this will be as it is now. So this is what then? X plus h cube minus x cube. Okay. So this is what then? X plus twice h cube minus x plus h cube minus 2. Okay. So plus x cube. Okay. So now see, we'll expand this. This is what x cube plus 3x square twice h. That means 6x square h. You have to take the square of the first one and second will be as it is. Now we have to take the square of the second one. This is 4h square. This will be as it is and into 3. So this is what into 3 means it is 12 now. 12x h square plus cube of this one 8h cube. Okay. So this is the expansion of the first one minus 2 into this is the x cube. So this is very simple now. 3x square h plus 3x h square plus h cube minus x cube. Now see how many x cube. So this is x cube. This is minus 2x cube minus x cube. So x cube is very good. So there is no x cube now. We will collect a term of x square now. Collect it. This is 6x square h. This is what? Minus 6x square h minus 6. Okay. So this is correct now. So this what x cube get cancelled. 6x square get cancelled. Now we collect the term of h now. So this is what, see this is 6h square and this is 6 get cancelled. So this is 12xh square. Okay. Now xh square and xh square is here. This is minus 6 now. So this will what minus 6 and this is 12 now. So this will be 6h square. Then what 8h cube. So this will be plus 6h cube. Plus 6h cube. Okay. So this is the your required answer. So you may take a xh 6h square common. Then this is what x plus 1. X plus 1. Okay. So if you are interested to take the common, then you can take the common. Otherwise keep as it is. So this is the correct answer. 6h square plus 6h cube. This is the correct answer. If you want to take the common, you can take common. Okay. Now next. Prove that. This is very important problem. Prove that f of x g of x is equal to g of x f of x minus f of x g of x upon g of x plus h. Okay. Solution. So what we'll take? We'll take RHS now. We'll take RHS. So this is what g of x delta f of x minus f of x delta g of x upon g of x into g of x plus h. Okay. So now this is what then g of x into. So what delta f of this is what f of x plus h minus f of x minus this is what f of x. This is what then g of x plus h minus g of x upon g of x plus h. Now see this g of f of x, this is minus and this minus must become plus f of x into g of x. So f of x into g of x is here, but this is minus, this is plus now here. So it will get cancelled. So only these two terms remains. G of this f of x plus h minus f of x into g of x plus h upon g of x plus h. Right? Now we separate. This is what a minus b upon c. So I can write a upon c minus b upon c. A minus b upon c is equal to a upon c minus b upon c. So this we can write. So this upon this will what then? F of x plus h upon g of x plus h minus. So this will what then? F of x upon g of x. So this is nothing but first forward of f of x upon g of x. That is your RHS. Okay. So it is better to do from LHS instead of LHS. If you are taking LHS, then you have to think on this one. Which one is added and which one is subtracted. You have to add and you have to subtract it. That you have to think a little bit. So it is better to use take the RHS, simplify the RHS. Easily you get easily you get the LHS now. This is LHS, not RHS. This is LHS. Okay. So this is very simple proof. Just we are applying your forward difference operator. With the help of forward difference operator, we easily will get the result now. This is very simple. Now, next. Prove that e raised to hd where d is equivalent to d by dx. Okay. Solution by Taylor series expansion f of x plus h is equal to f of x plus h f prime x plus h square upon 2 factorial f double prime x plus h cube upon 3 factorial third derivative x plus dot dot dot. Okay. So e of f of x is 7 f of x plus h. So this is e of f of x is 7 f of x plus h d f of x plus d f of x plus h square upon 2 factorial d square f of x plus h cube upon 3 factorial d cube f of x plus dot dot dot. So we can write this as 1 plus hd plus hd upon 2 factorial plus hd square. Okay. hd cube upon 3 factorial plus dot 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 f of x, and this is nothing but e raised to hd. This is nothing but e raised to hd f of x. Right? We know that the Taylor series expansion of e raised to hd is 1 plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So this is e of f of x. This is your e of f of x. So therefore e is equal to e raised to hd. Okay, is equal to. Okay, so this is also very simple proof of this. Next, evaluate del square 5x plus 12 upon x square plus 5x plus 6. Okay, so 5x okay. Solution. So what we can do this one. So h is not given to you actually here. Okay, so taking okay, interval difference is given to you. Taking interval differencing being unity. That means what here? You are given that h is equal to 1. So what we will do? We will find this now. Solution 5x plus 12 upon x square plus 5x plus 6 is equal to del del 5x plus 12 upon x square plus 5x plus 6. Okay, so this is nothing but a del. You have to replace x by x plus 1. So 5x plus 1, not x plus h. So you have to take h is equal to 1 now plus 12. You are given that interval difference is 1. That means h is equal to 1. Just say only replace x by x plus h. But your h is 1, right? H is 1 now. So this is what is x plus 1 square plus 5 into x plus 1 plus 6 minus this will be as it is now. 5x plus 12 upon x square plus 5x plus 6. This will be as it is. Okay? This will be as it is. Okay, so we can simplify it, but it is very complicated to solve this one. Okay, so directly we will apply this one. This is what? This is equal to what? So we will replace x by x plus 1 and we will subtract this as it is. This is 5 of x plus 2 plus 12 upon x plus 2 bracket square 5 of x plus 2 plus 6 minus 5x plus 1 plus 12 upon x plus 1 square plus 5x plus 1 plus 6. Okay, minus this will be as it is now. This is what? 5x plus 1 plus 12 upon x plus 1 square plus 5x plus 1 plus 6 minus 5x plus 12 upon x square plus 5x plus 6. Okay, so this is equal to 5x plus 2 plus 12 upon x plus 2 square plus 5x plus 2 plus 6 minus 2 times. Okay, minus 2 times 5x plus 1 plus 12 upon x plus 1 square plus 5x plus 1 plus 6 minus become plus 5x plus 12 upon x square plus 5x plus 6. Okay, so this will be the correct answer. So you can simplify this only this what 5x plus 10 plus 22 plus 12 means 5x plus 22. You can write this one. This is what is 10x plus 44. So this is 5x plus 12. Okay, so if you are interested, you can simplify this one. Just expand this one, correct x square, correct x, correct the constant. Here also this, and then take the LCM of this one. So you can do this one. Okay, so otherwise keep as it is, because what the simplification is very complicated now. So that you can do. Okay. Okay. So according to me, this is enough now. Next, construct the forward difference table for the following set of values of f of x is equal to x cube plus 5x plus 7 for x is equal to minus 1, 0, 1, 2, 3, 4, 5. Compute the table to obtain f of 6 and f of 7. So what you have to do? So forward difference table we have to construct. Okay, and with the help of that one, you have to find the value of f of 6. See, you have the minus 1 to minus 5. We can do this one. Okay, but with the help of the forward difference table, we have to find the values of f of 6 and f of 7. That we have to do now. So this will be the extrapolation. It will be because what 6 and 7 are the out of the interval now. This is 6 and 7 are out of the interval. Okay. Solution. Given that f of x is equal to x cube plus 5x plus 7. So what we will write? We will write here x. We will write here f of x. So now we'll put minus 1 here. Minus 1, 0, 1, 2, 3, 4, 5. And you want 6 and 7 with the help of the table. So we'll write the value of f of minus 1. Put x is equal to minus 1 here. Minus 1 cube is minus 1. Minus 5, minus 6. So it will be 1. For 0 it is 1. So for this is what? 7, 8, 13. So this will be 13. For 2, is it? This is minus 7. Take this as minus 7. This is minus 7. Okay. We'll take this as minus 7. Then the values are, just I write the values here. Just I have calculated this. Minus 13. This is minus 7. This is minus 1. This is 11. This is 35. Then this is 77. This is 143. And this is x and this will be y. We will take this value x and y. Okay. So now we find delta f of x. So minus 7 minus 30 minus 7 minus of minus 13. So plus 13. So this is what then? This is 6 now. This is 6. Okay. Minus 1 minus 7. So again this is 6 now. Minus 1 minus of this is plus 6 now. So this will be 12 now. This will be 12. Okay. 11 minus of minus 1. 35 minus 11 is 24. 77 minus 35. 77 minus 5 is 42. This will be what? 42. It is 40. 77 minus is it true for 1 for 4 is it correct? We will check this. We will check the value at 4. So 4 is 64. Okay. So we got 4 cube. So 64 plus 20 that is 84 minus 7. So for minus 7, so it is 77. It is correct. Okay. 77 minus 35. This is what 2 and this is 4. Okay. So 42 is correct. Then 143 minus 77. So this is what 13 minus 7. So that is 6 now here. Then 1. So 14 again this is 66. This will be 66. Then x minus 43. Then y minus x here. then 1 minus x here. So actually what? We'll find f of 6 only here. We'll find f of 6 only. Okay, so instead of that by table, we'll find f of 6 only. Okay, so what you have to do now? You have to find del square f of x. So what? 6 minus 6 is 0. So this is 6. This is 12. Then 24 minus 12 is, okay, 42 minus 24. 42 minus 24. 42 minus 24. This is 8. 18 now. This is what? 18. So this will be 18. Then 66 minus 42. 66 minus, you have to use the calculator actually. 24. So this will what? 24. Okay. 24. Then this is x minus 143 minus 66. So this is 9, 10, 2. Okay. So 209 minus 209. Then you have to find del square f of x. You have to find del square f of x. Del square f of x. 6 minus 0 is 6. This is 6. This is 6. Again this is 6. This is 6. Then this will what then? X minus. So 209. 24. So 13. So this is 3. 233. 233. And so on. Okay. So we go to del cube now. This is cube now. Del to the power 4. Find the del to the power 4. So it will be what? 0, 0, 0. 0, 0, 0. This is what? 2 minus 230. X minus 230. 239. 239. X minus 239. X minus, this is 0. X minus 239. Okay. Now here what? So del square f of x. So see, all here are 0. Or this minus this. See how many here? So this minus this is 1 0. This minus this is second 0. This is third 0. Okay. So here what? Here. So therefore what? Del to the power 5 f of x. This is what then? 0. This minus is 0. Then x minus 239. Del to the power 5 f of x is what? 0. X minus 239. 239. And then 6 f of x is equal to x minus 239. Okay. So how many values are there? 1, 2, 3, 4, 5, 6, 7. So 8, 7. So that means what here? Something is wrong here. So 1 square, del square, cube, 3, 4. This is what here? It will be 6 and it will be the 7. It will be 6 and it will be 7. So what here? These are 6 values. 0. This is 1, 2, 3, 4, 5, 6, 7. Okay. So that means what here? Del to the power 7 f of x is equal to 0. So that means what here? X minus 239 is 0. This implies that x is equal to 239. So what is x? X is what? F of 6. X is what? F of 6. F of 6 is equal to 239. So in this way you can calculate the values of this one. Okay. So f of 6 is unknown. So now you may replace here what? 239 and then here what? Replace x is at 239 and do all those things. Okay. And write this f of 7 and y. So they do all the things. Okay. So you will get the values of this one. Prove that delta u x minus n is equal to ux plus n ux minus 1 plus n into n minus 1 upon 2 factorial ux minus 2 minus n into n minus 1 twice n minus 1 upon 3 factorial ux minus 3 plus dot 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 plus minus 1 raised to n ux minus n ux minus okay solution. So we'll start from RHS now. RHS okay ux. So I hope that you can write this. Okay, I hope that you can write this. Okay, so I'll write this ux as it is plus n e raised to minus 1 ux plus n e raised to minus 1 ux plus n into n minus 1 upon 2 factorial e raised to minus 2 ux, right, plus, oh this should be plus, okay, plus this is plus, okay, so plus n into n minus 1 twice n minus 1 upon 3 factorial e raised to minus 3 ux plus dot 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 plus minus 1 raised to, okay, so we'll keep this minus as it is now, it may be minus now, okay, minus minus, okay, so minus e raised to minus n ux now. So this is nothing but if I take common 1 plus n e raised to minus 1 plus n into n minus 1 upon 2 factorial, this is e raised to minus 2, this is e raised to minus 2, so e raised to minus 2 plus minus n minus 1, okay, this should be plus actually, plus n into n minus 1 twice n minus 1 upon 3 factorial e raised to minus 3 plus dot 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 minus 1 raised to n e raised to minus n ux, this is ux now, and this is same as 1 minus e raised to minus 1 raised to n ux, and this is 7 1 minus 1 upon e raised to n ux, so this is 7 e minus 1 upon e raised to n ux, so this is 7 just we have proved e of raised to n, okay. So prove that this is delta n now, okay. So now this is what delta n e raised to minus n ux, so this is what delta n ux minus n now, okay. So just we have proved this, that will be your RHS, So we'll correct this problem here, we'll write this as what minus plus minus, okay. Now this will write minus plus, now this is minus, we'll correct this problem, whatever there is a printing mistake in the, this is minus plus, this will be the minus, okay. Now the problem is correct now, okay. So this is the correct problem. So now this is what 1 minus e raised to minus 1n, this is the binomial theorem, so this is not the twice n minus 1, this is n minus 2 now, this is n minus 2, not this is twice n minus 1, this is n minus 2, okay. So this is n minus 2, n minus 2 binomial theorem. Okay, so now this is the corrected problem. Now prove that this. Okay, so now this is the correct solution of the problem. Okay, so we are correct now. Next, prove that e raised to x u naught plus x delta u naught plus x square upon 2 factorial del square u naught plus x cube upon 3 factorial del cube u naught plus dot 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 is equal to u naught plus x u1 plus x square upon 2 factorial x u2 x plus dot 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 plus dot dot dot. This is not x, it is just this. Okay, solution. So what we'll do, so we start from LHS now. So LHS is equal to e raised to x u naught plus x delta u naught plus x delta u naught plus x square upon 2 delta square u naught plus x cube upon 3 factorial del cube u naught plus dot dot dot. Okay, so this is equal to e raised to x into 1 plus x plus x delta is what x delta plus x delta square upon 2 factorial. Okay, plus x delta cube upon 3 factorial plus dot 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 u naught plus dot dot u naught. So this is nothing but e raised to x. So what is this? This is 1 plus x plus, so this is what e raised to x delta u naught. So this is nothing but e raised to x 1 plus delta u naught. So this is nothing but x e raised to xe u naught. This is operator now, right? So we'll expand this now. So what we get then? So this is what we'll expand. This is 1 xe plus x square e square upon 2 factorial plus x cube e cube upon 2 factorial plus dot 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 u naught. So this is what u naught plus x u naught plus x square upon 2 factorial e square u naught plus x cube upon 3 factorial u naught e cube u naught. This is e square u naught plus dot dot dot. Okay, so this is u naught plus x e1. U naught is same as e1, e square u naught, just you have to add this. This is what then x square upon 2 factorial u2 plus x cube upon 3 factorial u3 plus dot dot. Okay, so we get the required result. Okay, so we are through. So these are the problems like the how to operate the forward difference, backward difference, and shift operator. These are the problems on it. Okay. So I hope that you understand this one. Find y5 and y6 when y0 is equal to 9, y1 is equal to 18, y2 is equal to 20, y2 is equal to 20, y3 is equal to 24. The third difference being constant. Third difference being constant. Okay. Solution. The third difference is constant. This implies that fourth and fifth difference are zero. Fourth and these differences are 0. So that is 10 to the power 4 y0 is equal to 0. 10 to the power 4 y0 is equal to 0, and 10 to the power 5 y0 is equal to 0. Okay. So we'll write, okay, so no problem for this one. This problem may be solved with the help of the constructing the table and without the constructing the table. So what we do, we'll do without construction the table. So this is what 1 plus e. Okay. So this is what then delta. So what is the relation? 1 plus delta is equal to e now. So this implies that delta is equal to e minus 1. Delta is equal to e minus 1. So we can write this what? E minus 1 raised to 4 y0 is equal to 0. Right? So this is what then. This is what we can apply the binomial theorem. 4c0 e raised to 4. My alternate plus minus 4c1 e cube, because there is 1. Okay. So plus 4c2 e square minus 4c3 e minus become plus now plus 1 right. So this is what operator on y0, this is equal to 0, right. 4c0 is 1, so this is what e raised to 4 y0, okay. So I write here now e raised to 4 y0 minus 4c1 is 4, so this is 4 e cube y0. 4c2 is what? 4 into 3 upon 1 into 2, so this is 6. So 6 e square y0 minus 4c3 is 4, 4c3 is 4c1, and that is 4, so that is 4 e y0 plus y0 is equal to 0. We have taken y0 like this. So e raised to 4, this will what? y5, that we want. You want y5. Okay, with this you want y5 and y6. Okay, you want y5 minus 4. So this is what? Y3 plus 6 y2 minus 4 y1 plus y0 is equal to 0. So y5 is equal to 4 y3 minus 6 y2 plus 4 y1 minus y0. So 4 into y3 is what? 24 minus 6 into y2. What is y2? y2 is 20 plus 4 into y1. What is y1? Is 18. y0 is what? 9. y0 is 9 and this will be what? 74. This will be 74. Check whether it is correct or not. Okay. So easily you can correct this one. So here also you can do this. What? 18 to the is 36. This is 72. This is 72. Okay. Or you may take here what? You may take here 4 common. You may take here 4 common. Okay. So if 4 common, then this will be what? 42. See here. 42 into 4. This is what? 168 now. 168 plus this is what? 72 plus 72. So this will what? Then this will be okay. So this is what? So this is 120. This is 120. We will subtract this 120. Okay. So this is what? Then 48. This will be 48. Okay. This will be 40. Up to this is 48. Then this is what? 72 now. This is what? 72. You have to add this. If you add 72, this is minus then. Okay. Minus 9. So check whether this is correct or not. So you have the calculator. Easily you can find. So no need to actually what? 4 into 24 minus 6 into 20 plus this. Okay. So check whether this is correct or not. Okay. So whatever the value, you will write this. Whatever the value, just you write this. Okay. Now, so once you got 5, then you may write this is what? 5 now here. You may write this as 5 because you got y5. Right? So now here what? So we'll use the binomial theorem. So this is the binomial theorem now. So with the help of the binomial theorem, you can find the value of this one. Okay? So I hope that you understand this one. So this is what without constructing the table. So we did this. So I think you understand this one. So we will stop here. Okay? Thank you.